Greetings and welcome, friends. Mr. Waddy here. We were talking about special right triangles. It turns out that there were some special situations in which you had triangles that had interior angles that were 45, 45, and 90, and that the ratio of their sides had a consistent ratio for all 45, 45, 90 triangles, as well as another batch called 30, 60, 90s. So here we go. This one here, this is an isosceles triangle by base angles theorem. We also know that those are congruent, and then triangle sum, a little bit of work substitution, whatever. That's a 45, 45, 90. Turns out the legs of a 45, 45, 90 are always congruent to each other. And if I want to go from a leg length to the hypotenuse, what do? I multiply by the square root of 2. You could do Pythagorean theorem every time, but hey, these are special, so let's use these shortcuts that are available to us. So that means x is going to equal 5. Man, that was a good Waddy sneeze. Add that to the Waddy remix. Thank you. 5 root 2 times root 2, that's 5 times 2, which is 10. So the hypotenuse here is 10. Nice. All right, how about this one? Here I know the hypotenuse, but I don't know the length of the legs. Those legs would be congruent to each other. How do I go in the other direction? Divide by rad 2. So I'll have x is equal to 9 over rad 2, but I cannot leave a radical in the denominator. I got to multiply by rad 2 over rad 2. Right, because that's equivalent to 1, and the benefit of that is I'll have 9 rad 2 over root 2 times root 2 is root 4, which is just 2. So this is the length of the legs in that situation. So for 30, 60, 90 triangles, let's see, perhaps you guys remember. Color editor, what? Oh dear, you guys are spotting that? You know what's up? I know what's up. It's giving me the old classic invisible toolbar thing. Yeah, see that? Isn't that weird? I'll drag that to my other screen. Here, sorry for breaking the fourth wall. Bam, there you go. So, now I can't click on the invisible toolbar. So for any 30, 60, 90 triangle, I can go from the short leg to the hypotenuse by doubling it, and I can go from the short leg to the long leg by multiplying by rad 3. Okay? And then you can do those things in reverse if need be. So for question 7, this is the short leg. How do I know that's the short leg? Yeah, it's opposite the smallest angle. Yeah, this is going to be 60 here. So to go from 9 to y, I double it. I'm going to get 18. To go from 9 to x, I'll just have 9 square roots of 3. Right, that's el más rápido. Okay, to go backwards, so here I'm starting at the hypotenuse. It's opposite the 90. Oh, there we go, I undid that. I'm going to divide by what? Yeah, it'd be really nice if I could have divided by the square root of 3, but... so what's that going to be? 6 rad 3. And then to go from that to that, the short leg to the long leg, I multiply by rad 3. What's that going to be, 18? So 6 rad 3 times rad 3, 6 times 3, 18. Yeah, there we go. So it's just a matter of multiplying or dividing by these appropriate ratios. Oh, look at this. That's not a triangle. But I can find the height here using Mathemagic. If this little triangle here is a right triangle, which it is, and it's a 30, 60, 90. Here's the hypotenuse, which is 4. So 4 divided by 2 is 2, and the height is going to equal 2 square roots of 3 when I multiply that short leg by root 3, right? Right. Multiply that short leg by the square root of 3. That's very Waddy quotable. Oh, that's a Waddy quote. So, although are you going to waste quotation marks on everything that's already on a Twitter account called Waddy Quotes. I mean, this is a decision you've got to make now, because otherwise you're losing 2 characters of the 140. Forever. For internal consistency. So, alright, the question here is, this is the Wheel of Theodorus, classic game show. What, if any, are 45, 45, 90 triangles here? The 1, 1, root 2. This one right here, I agree, is a 45, 45, 90. Alright, and then it says, which triangles, if any, are 30, 60, 90? All of them? Yeah, I think it's just gonna be... Okay, so this one, right? Not this one? Okay. So yeah, to go from the short leg to the long leg, that's square root of 3 times longer. But wait a minute. To go from the short leg to the hypotenuse, it should be double. Is it? What is the square root of 4? 2. It is doubled! Yeah, so there we go. So that is happened to be the float of 6 to 90. Because those ratios maintained. Alright, so anyways, thank you for watching, mis amigos de internet.